So hello everyone, welcome to the engine channel. Today we have this engine. Today we're going to take apart this engine. It is a Mercedes-Benz 447. It's an inline 6 turbocharged. The turbo has already been removed. The exhaust manifold has been removed. The turbo has been removed, so there's no turbo. The engine operates in this position, meaning it's lying down. This engine is from a bus, from a Mercedes bus. What's the reason for removing this engine? This engine started knocking. The bus was on the route and the driver heard strange noises, that is, knocking in the engine, and the oil pressure dropped. The driver turned off the engine and the bus was stowed in. Well, it's clear that if the oil pressure dropped, we need to look for the cause somewhere around the crankshaft, right? The main bearings, connecting rod bearings, possibly the oil pump drive, and so on. When the bus was over the inspection pit, they removed the exhaust manifold. I decided to check each cylinder. So if we had some issue with a cylinder, like say the piston seized to the liner, or for example a valve seat dropped or a valve broke apart, then the exhaust manifold, the exhaust port on one of the cylinder heads would be wet. For example, it could be diesel fuel, oil, or something similar. We removed the exhaust manifold and checked all the cylinder head ports were dry. There was carbon buildup but no moisture. So that means the cause isn't in the valve seat, not in the valve, not in the head, and not in the cylinder. The cause of the knocking is somewhere in the crankshaft itself, in the journals, the connecting rods, the main bearings, and so on. So for this reason we decided to remove the engine, because you can't do anything with the crankshaft while it's in place, and you can move it or replace anything there. We removed the engine and rinsed off the worst of the dirt at the car wash. My task now is to take it apart, figure out the cause, find out why it's knocking, and also see what consequences this knocking has caused. Then, while the engine is out, we'll completely disassemble it anyway, meaning we'll remove the heads and take out the pistons. Basically, we'll check the overall condition of the engine, and once we know the reason for the knocking, we'll also know overall condition of the engine. After that, a decision will be made about what to do with this engine. This is our company's engine from our company's bus, so I don't know if this engine will be reassembled or not, but most likely it will be, because the bus is still in pretty good condition. Well, comparatively, yes, compared to all the other buses in our company. So, what else do I want to say? There's no clutch left. The flywheel, pressure plate, and disc were used for another bus that just needed a clutch replacement and return to service. This bus, however, will likely be out of service for a long time. The clutch was removed from this engine and given away, and that other bus is already back in service. So what else do I want to say? If we take a look, for example, there are sensors on the air manifold. Also, if we look at its cover, there were sensors installed here, and so on. So, at one time, this engine was set up for electronic throttle control. There was an electronically controlled injection pump here. That was maybe 8 or even 10 years ago. I don't remember exactly. I repaired this engine, we converted it to mechanical throttle control. Here's the fuel injection pump with a mechanical throttle drive for the throttle cable. That's the reason for it. The throttle stuck and the engine ran away. Electricians couldn't find the cause, so they switched the engine to a mechanical pump. So they changed the fuel pump, changed the camshaft, changed the nozzle. And basically it's the same as the engine I have now. A used replacement engine from Poland. This one has served me well. We're not sure, maybe 10 years, I can't recall exactly. Let's begin, the oil's already drained. As I said, now I need to remove the compressor, for example. I think the compressor, the air conditioner, is mounted on this plate. There are fuel TED pipes, tubes, the fuel pump, and so on. So we disassemble everything from the top. Then we hang it up, remove the oil pan, and take off the cylinder heads and so on. That's it. So, that's our scope of work for today. Let's get started. continue. I just took off the oil pan and immediately noticed metal shavings around the third cylinder. So, the third cylinder, most likely, yeah, we can see it here. So we can see that the bearing in the third cylinder is damaged, meaning the connecting rod bearing got welded to the journal. We can see there are metal shavings here. And what else do I see? I see that the crankshaft is broken, so there's a crack right here. It's not clear what happened first. Either the bearing welded first, causing the crankshaft to break, or the crankshaft broke first along the journal. This damaged the connecting rod bearing. Now we'll take it apart to check. Well, the fact is that the crankshaft is cracked. Here's the crack. It starts here and goes off this way, and on this side I see it goes onto the journal as well. So what does it tell us if the crankshaft is broken? The main bearing seats will need to be machined at a shop, or the block will have to be replaced. Well, obviously the crankshaft needs to be replaced with another one. This connecting rod also needs to be replaced. For now, these are the preliminary results. Let's keep disassembling. I removed the injectors, rocker arms and push rods. Now I just need to remove the cylinder heads. This impact wrench can remove the cylinder heads because it lacks power and has a 1T2-inch square drive. I have to loosen them with a breaker bar first, then use the impact wrench to remove them. And finally, I got this kind of impact wrench. It's a 3 to 4-inch drive with a 3 to 4-inch square. I think this impact wrench can easily remove the cylinder heads, flywheel, main bolts, connecting rod bolts and more. So now I'm unpacking it, checking what's included. I don't know yet if the fitting will fit, but it looks like it should be the same. So in the set we have 3 impact sockets, a 32, a 36 and a 41 all 6-point. Alright, there's nothing here. Alright, and here's the gun itself. Powerful, heavy. Alright, we don't have the adapter. Let me check, I should have one somewhere. So I removed the heads. The gun works great. It unscrews the bolts without any problems. I also already tried to unscrew 2 main bolts. It also loosens and tightens the main cap bolts easily. So now it will be much easier to work with the engine because, well, unscrewing these 336 bolts by hand also takes effort, time, and so on. Everything here is much simpler, much faster. So the impact wrench is excellent, thanks to the people who helped me buy it on the 3rd cylinder. And on the 5th, well, for now, visually the pocket area is eaten away on the 3rd and 5th, so here we have the pocket area. And we can see that the pocket area is already misshapen, and the opening is misshapen too. On the 6th, it's basically fine. On the 4th, it's fine. On the 2nd one, I don't know, it needs to be cleaned. On the 1st one, everything seems fine too. So, the problem is with the pocket areas on 2 heads. Regarding the heads, I'm not sure. I'll wash, clean, and inspect them to decide if machining is needed. Well, otherwise, I'll take apart the valves, check the guides, as usual, everything as always. What do I do next? Next, I need to remove and disassemble the front here. Take off the mount, the brackets, the timing cover, the pump, and the engine mount. Then remove the cover, take out the pistons, and take out the crankshaft. But to be continued. Time. So I removed the third piston, unbolted the third connecting rod, and took out the third piston. And what do we see? We see that the bearing shells have basically turned into foil. Into this tin, the bearing shells are completely chewed up. And our crankshaft is not completely broken. That is, here we have a crack. Right here along the cheek there's a crack. There's a crack along the journal itself. But it hasn't completely snapped. But when we take it out, it might break into two pieces, or maybe not. We'll see about that. So what else did I notice? This connecting rod here, it's new. So all these connecting rods, 5 of them, are still the original German ones from the factory. But this particular connecting rod is from the BF company. The numbers font is different. There's a BF number at the bottom and the BF logo is here. On the original connecting rod, the number is stamped differently here. So I've noticed more than once that these connecting rods from BF, they haven't performed well, they don't behave well. So what's the problem with these connecting rods? So when it's assembled and new, if we measure the inner diameter, it's basically perfect. The ideal, correct shape. That is, it's completely round and the size is the same everywhere. But over time, what happens to this connecting rod? It becomes oval shaped. That is, in these spots right here, we have the greatest load. And at 180 degrees on this side, on the cap, it also gets the greatest load. And over time, it becomes oval shaped. So in this spot, it gets stretched. And in this spot, it gets compressed. I've noticed this many times. And as we can see, the problem is exactly with this connecting rod. Meaning, out of the 6 rods, it's this one. The one from the BF company, which is not the original one. So what do I think? I think the connecting rod got deformed. The bearings start to move around, and over time, basically they seized up. One bearing got stuck on another, spun around, welded itself to the rod, and welded itself to the crank journal. The driver didn't stop or turn off the engine right away, so he kept driving for a bit. But that's understandable, because the engine is in the back. The bus is, I don't know, 15 meters long or however long it is. There's sound insulation and so on. Well, in general, it's hard to hear right away that the engine started knocking and so on. So the bearings seized up. It turns out that this journal is holding, trying to keep things in place while the other journals, not the shaft, are rotating. As a result, the crankshaft experiences torsion and bending loads and so on. That's what happens. That's the result. But the cause of the failure is the connecting rod. That's my opinion for now. That's what I think. It's all due to the connecting rod, since I've had this issue multiple times and these rods keep deforming. And probably I won't install them anymore at all. So now I'm removing 2 more pistons, taking them out, removing the caps, taking out the crankshaft, and we'll see whether it's broken or not. Yeah. So about the engine, I took the engine apart, took out the camshaft, and basically didn't find anything else particularly interesting. The main problem with this engine is, well, the crankshaft, which is the consequence, but the cause is the connecting rod. As I mentioned, the connecting rod is from BF company. I think the connecting rod bent, causing the bearings to get squeezed in one area and loose in another, then welded to the crank pin and spun. Since the engine kept running for a while, it turned out that when they were towing it, they started the engine again. Basically, they needed to pump up the air and so on. Since the engine had to keep running for some time, we can see that a crack appeared. But the crankshaft didn't break completely, it didn't snap. You can't use it anymore. It's definitely scrapped now. The crack starts here around this spot, and you can see it extending further. And also along the journal, it goes all the way along the journal like this. Then it moves onto the crank web and goes off in this direction, E. So it turns out that the crankshaft is cracked more than halfway through. I tried lifting it with a tester by this journal, E, to see if it would maybe break off the crankshaft and so on. So it's still holding on tightly, but when you lift one end of the crankshaft, this crack moves and you can see oil seeping out from there. In my opinion, all this happened because of the connecting rod. If, for example, we had a regular standard factory original connecting rod, I think this situation wouldn't have happened. So, in a nutshell, here are the decisions made about the engine. The block isn't going anywhere. I mean, we're not going to machine the main bearing seats, so the repair will consist of replacing the crankshaft. We'll keep the old pistons, and maybe even the piston rings will stay the same. I just need to take them off, measure them, check the clearance, and so on. There were absolutely no complaints about how this engine worked. It didn't consume oil, it didn't consume extra fuel, it had good power, and it had no blow-by. So, basically, there were no problems at all. We're going to repair this engine with minimal investment, meaning we'll buy as few parts as possible. Maybe I'll replace the seals, maybe I won't. We'll see as we go. The only thing is I'll need to flush the block. You can see how much metal shavings there are. Flush the channel, basically clean the radiator, the heat exchanger, and so on. I might even have to replace the head gaskets. I'll install head gaskets with metal seals. Before, we used to buy Turkish gasket sets and they came with gaskets that had metal seals. As I mentioned before, I don't use those gaskets because they damage the block and the head itself, corrosion develops in that area. What else did I notice? One of the oil squirters is broken. I don't know the cause, and it doesn't seem close to the third one. Maybe it was like that before. I'll need to replace one oil squirter. Why is there this attitude toward these engines? Why are such repairs needed? Well, because I've said many times before, our company is losing its main route, which all these buses used to operate on. This engine has only a few months, maybe 6, left to work there. I'm not sure. Since there's so little time left, no one will invest 150,000 or 200,000, so we'll do repairs without major investment. So we have an interesting case here. The crankshaft, it didn't even break. There's just a crack. In my experience, I might remember a couple of such cases. So that's what we have here. Unique, interesting. So the decision was made to assemble this engine, although there was still some uncertainty about whether it would be assembled or not. The decision was made to assemble this engine, and in fact a certain number of new parts have even been purchased. I thought the repairs would be minimal with very few new parts, but we did end up buying some new things. I'll tell and show you everything as we go. As you can see, the block is already prepared. I washed it, cleaned it, and blew it out. The only thing left is maybe to run a tap through some of the threads and so on. we're keeping the old lifter. I washed the counterweights and main caps. Easy, now we'll install the crankshaft. The camshaft is also staying. I washed and blew it out too. Easy, we're also keeping the old sleeves, the sleeves. I cleaned off some corrosion, rust and so on. So here, where the seats for the seals are, I cleaned them. And inside here, where there was carbon buildup, I cleaned that too, and so on. There are already signs of cavitation on the sleeves. You can see the pits, and on the opposite side there are pits as well. Well, it is what it is. We're assembling it as is. So I'm starting the assembly. First I'll install the sleeves and the heat exchanger, then I'll lay the engine on its side and install the camshaft. Well, the lifter and the camshaft will be keeping the old bushings, and then I'll install the crankshaft. The crankshaft is already prepared for installation. I've polished it and blown out the oil channels as part of the crankshaft preparation. There are a few clips and I'm dropping those in now. Regarding the crankshaft, ours is different since the old one is broken, so we'll use another. So this crankshaft is a standard. It was prepared as a spare, you could say. Basically, it was just lying around in the workshop, and now it's spring. You can still see this much snow. The snow has started to melt, the roof started leaking, and basically all my spare parts got soaked there. You can see this kind of rust appeared on the journals, right? Especially here around the 6th and 7th main bearings. So you can see there's less rust in this direction, and here there's almost none. I tried polishing the 7th main journal. You can see that it polished up completely. There are no traces of rust left. It's just surface rust. All of this happened in just a couple of hours. I noticed that water was leaking there. I removed all the spare parts, kept them down, blew them out, and so on. So now my task is to polish all the journals. I know they're still within spec. I had checked and measured it before. I clamped it in the machine, moved the counterweights, and now we're polishing. Next we'll blow out the channels, get everything ready, and install the Kino roll. To install. I tried on the main bearings. The size of this journal is 103.98, but they're also 103.97 within these limits. So minus 0.02 to 0.03, which is within the normal range. All right, next we try on the crank pinch. We also see the size 89.97, 89.98. So again, minus 0.02 to 0.03, which is within the tolerance range. So that's how I prepared the crankshaft, and now we proceed to assemble the engine. So for now I'm working with what I've already prepared. The camshaft liners, crankshaft, we're assembling all of that, and then we'll move on to the next step. Next we'll address the piston issue. There's a problem with one connecting rod, and I couldn't find a replacement with a trapezoid shaped piston pin bushing among my parts. I do have connecting rods like these with cylindrical bushings, but they require different pistons. So I have a set of different pistons for these connecting rods, so maybe I'll be able to use them. I'll replace this with pistons and connecting rods from another engine already assembled. We'll return to this later. For now, let's focus on the previous task. Let's go. I measured how much the liners stick out above the cylinder block, and right now for all of them it's about 0.09 to 0.10 millimeters, within a tenth of a millimeter roughly. So I had to adjust it a little bit here. Somewhere I had to put two rings, a bit thicker, thinner ones over there, and so on, meaning a little variation. Now I'm marking cylinder liner in its place, and by position yes, by rotation. I make marks, take out the liners and install new rubber seals. Yeah. And then put the liner back. Nice black balloon back in place. And then I put the liner. And I put back in place. So. And I then put the liner back in place. I tightened this to 200 Newton meters. Now I'm setting the wrench to 300 Newton meters. We tighten all the bolts again to 300 Newton meters. Alright, that's it. The crankshaft is fully installed and tightened. That means the main journals are tightened, the pistons and connecting rods are installed, the rod journals are tightened, the counterweights are installed, and the bolts are also tightened. I use thread locker on the counterweight bolts. Let's check that each connecting rod moves freely. The crankshaft itself also has axial play. So I also turn the engine and check that the oil jets go into the piston recess, meaning nothing is hitting anywhere. There's no misalignment or anything like that. That's it. The crankshaft is installed and tightened. Now I install the front cover and the rear cover. As usual, I replace the oil seals there, and then we close the oil pan. Also, I installed the oil pan. I tightened the bolts, put the gasket on with sealant, everything as usual. The oil pan is not from this engine, it's from another one. So why did I decide to replace the oil pan? On the original oil pan from this engine, the thread here is stripped. I think it's already been drilled out to 14 millimeters or something. The original oil pan from this engine has welding here. It's been welded and so on. So what do I need to do now? Now I need to install a plug here, screw a fitting in here, and for the oil dipstick, install a bracket here for the alternator mount. Here I need to temporarily close off the oil filler neck with the plug. And right here, apparently, I'm missing one bolt. Here, the thread in the cover is for a size 10 bolt. Everywhere else, the thread is for size 8. But in this spot on the cover, it's for size 10. So now I need to take a drill bit and enlarge this hole, probably to 10 or 10.5, and put in a size 10 bolt here. I forgot to do this right away. After I had already installed the oil pan, that's when I remembered, or rather noticed, that the bolt was falling through. And I remember that the thread here is for a size 10 bolt. So that's the remaining work we need to do on the oil pan. And then once we're done with the oil pan, well, I don't know, we need to install the pulley, the water pump, the fuel pump can be installed, and the compressor, although I don't know, maybe I'll take apart the compressor to check the cylinder and the rings. Also, I still have the cylinder heads lying around unprepared, so I'll need to disassemble them and take a look. There, well, it's all as usual: valve, seal, seats, valve. Wash everything, blow it out, clean it. Alright, let's continue the assembly. I've spent some time working on the cylinder heads, so I'll briefly explain them. Since our engine was in working condition, I didn't really do much with the heads. I mean, I washed them, cleaned them, blew them out, took apart a few heads, checked the condition of the valves, did everything there, the seals and so on. Everything is working. I prepared the valve guides, cleaned the bolts and set out the gaskets. You can see that some of my gaskets are metal with rubber seals, and some are like these metal asbestos. I'll explain why in a moment. So if we look at these two cylinder heads, for example, on this one you can see the recess, the channel that's in the head but not in the block. It's in the correct shape, and here this type of gasket will fit well. You can see that its sealing is done with this kind of rubber ring. That is, you can see the imprint from this ring, and it ends up blocking this channel. So if we look at the neighboring head, we can see that this recess is corroded. Yes, it's been eaten away like this. For comparison, here you can see what shape and size it is, and on this head what shape and size it is. So if you put a gasket like this here, this ring doesn't cover it. You can even see it by the mark, but it was already practically right on the very edge. There was still some rust washed away here, some deposits and so on. I've washed and blown everything out. There's a chance that if I use a gasket like this, it won't seal or cover the corrosion, and since it's metal it won't hold, and so here we'll have something like coolant leaking. So we have two of these cylinder heads. I'm putting them on the 5th and 6th cylinders. I mark that this will be for cylinder 5, and then first, second, third, 1, 2, 3, 4. We'll be using these kinds of metal gaskets. I try to assemble everything with these metal gaskets that have a rubber seal. But in this case I'm kind of in a dead-end situation. I either need to replace the cylinder heads, which I don't have right now in good condition, or I can solve the problem using these gaskets. So that's the situation. Let's start installing the heads. To be continued. To be continued. To be continued. So my engine is almost assembled. All that's left is to install the compressor, this the exhaust manifold and the clutch pressure plate, and we'll have a new clutch pressure plate with a disc. So we'll get back to the pressure plate later. I'll probably paint the manifold. So now I need to prepare it for painting. I'll paint the manifold separately, then I'll paint the engine separately, and only after that I'll install the manifold onto the engine. Now about the compressor, I want to take the compressor apart. I still have the compressor, it's just lying around, I only wiped it off and haven't cleaned it yet. So I still want to take it apart and check the condition of the rings. That is, to check the condition of the cylinder itself and the piston rings. I likely won't disassemble it further. I'll just replace the rings, replace the gaskets here and check the plate, etc. So right now I'm working on the compressor, installing the compressor. Then I'm preparing the engine for painting, preparing the manifold for painting, and installing the manifold. I don't know yet if I'll start it or not. It depends on the circumstances. For now I'm working on what I mentioned. Let's go.
situation.
So I installed the compressor and did minimal repairs on it, meaning I replaced the piston rings, replaced the bearings, replaced the valves, cleaned off the carbon deposits, and put in new gaskets. So just minimal repairs. I installed the compressor, tightened it, so basically that's it. The engine is almost assembled. What am I doing now? Now I'm preparing the engine for painting. So as usual, I'm covering the grooves with tape, some fittings, some sensors, and so on. I also need to install the exhaust compressor. The manifold is already prepared, the exhaust manifold. I also need to repair the fork. I have a ring kit for that. I have a ring repair kit for the clutch fork. So as you can see, the shaft rotates like this. There are needle bearings inside, and apparently there's some wear on the needle bearings. Also, I still need to install the starter. I'll be painting without primer, just like I did with the previous engine. I painted that one without primer, and when I took it apart again, it seemed to me that the paint held better, like it stuck to the metal more firmly than when it's applied over primer. So we'll try painting this engine without primer as well. Let's see how it turns out. So I don't know what color I'll paint it yet. I'll check if I still have some yellow paint left. Then I'll paint it the same yellow as the D3900. There. E. So I installed a new clutch pressure plate and a new clutch disc. Before installing the disc, I took it to a lathe and checked for runouts. Well, basically lately I haven't come across any bent discs in it for quite a while, but there were a few cases when a warped disc was installed without checking. The pressure plate moves away, but there's not enough distance for the disc to disengage, and the gears won't engage, so we had to remove the gearbox several times. It was a hassle, and after that, I always try to check the disc for runout every time. That's it. I installed the disc, installed the pressure plate, already adjusted the clutch. Basically I set it up about halfway here. These levers, well, you loosen these bolts and these posts. You can move this pad closer to or farther from the gearbox or release bearing and adjust everything. My engine is fully assembled, painted and ready. Next I'll run it, prep it for startup and start it right here on the table. There will be a separate episode on starting this engine. That's it for this episode on assembling the engine. I'm going to wrap it up. That's the kind of video we ended up with. Thank you all for watching. Good luck to everyone and goodbye.